Next problem, please. See. Please go to the slide. All of you, please read it out once. Read it out and you will understand in a better way what is given there. So, on a Saturday night, 20% of all drivers in USA are under the influence of alcohol. On a Saturday means weekends, because they are all weekends. Saturday, Sunday, they used to take alcohol. So, the data given that 20% of drivers in USA are under the influence of alcohol on a particular Saturday night. Next, the probability that a driver under the influence of alcohol will have an accident is 0.001. The driver under the influence of alcohol will have an accident is given to be 0.001. The probability that a sober driver will have an accident is 0.0001. If a car on a Saturday night smashed into a tree, the probability that the driver was under the influence of alcohol is. So, here two cases are occurring. Number one, the driver without alcohol, without taking alcohol. Number two, the driver taken alcohol. Two cases are there. So, whenever drivers are of two types, one is under the influence of alcohol, another one is not under the influence of alcohol. Then the accident may happen with the first driver or it may happen with second driver. So, what is required there? We must know the probability that the driver was under the influence of alcohol. Driver was under the influence of alcohol. So, here understand that what is A here? Simple. You can write it in one step. What is required? Here, Bayee's theorem says that required probability is nothing but favorable probability upon total probability. Because these are the objectives. If it is subjective, you have to write all the steps. You have to consider A, B1, B2, B3. If three events are there, you have to write all of them. But because it is objective, you have to have more pace while working out the problem. So, simple thing, the moral of the Bayee's theorem, the story of the Bayee's theorem is nothing but total favorable probability divided by total probability. So, what I'm doing now, I'm taking first of all total probability. How many drivers are under the influence of alcohol? 20%. So, 20 by 100. I have written that. We have chosen the alcoholic driver now. Next step. The driver under the influence of alcohol will have an accident is 0.001. That is 0.001 plus. That means now it is the accident occurred due to the driver under the alcohol. Okay. Next. When 20% are under influence of alcohol, obviously 80% will be out of alcohol. That means without alcohol, without taking alcohol. Because of these drivers who are non-alcoholic, what is the percentage of getting an accident is 0.0001. You can see that clearly, please. Please see the data. 0.0001. 3 zeros are there. Okay. Now, what is our favorable probability in this case? What is a favorable probability? You can see the question that the probability that the driver was under the influence of alcohol. Why two cases here? It is under influence of alcoholic and it is not under the influence of alcohol. Which one we need? We need this one. We need this one. That is why it is favorable. Get it to the numerator. So, it is 20 upon 100 into 0.001. That's all. If you simplify that, you'll be getting the answer. It is simply, let me write in this way, 20 by 100 and it is 0.001 means it is 1 upon 1000. It is also 1 upon 1000 and it is 1 upon 10,000. Okay. Now, let us simplify this. Let us take this one common. this one common, 20 by 100 into 1 by 1000 common, then you will get 1 upon, getting cancelled. This is 1 upon 1 plus 20 taken common, 4 upon, and 1000 taken common, so that is why it is only 10. So what should it be? 10 upon 14. 10 upon 14 is nothing but 5 upon 7. See the option there. It is option 3. Option 3. Okay. Let me explain you again. First of all, whenever you have these many concepts in the probability, how to understand first, after going through the problem, how to understand that Bayes' theorem is to be applied first of all. So that's important thing here. Because getting an accident or to have an accident is now divided into two cases. Two cases. What are two cases here? With an alcoholic driver, the accident may happen. With a non-alcoholic driver, the accident may happen. So in this case now, he has to give us the getting an accident with an alcoholic driver. The probability must be given. Must be given. That is given clearly. You can see that. That's given. And in the second case also, the probability must be given. That is also given. So both must be given. Then only you can solve the problem. So both are given. And what we need is alcoholic driver. That is why it is sent to the numerator. And to simplify, you got the probability of getting an accident with an alcoholic driver. Okay, so this is the Bayes' theorem. Please go to the next slide. Yes. The ratio of the number of trucks, along a highway on which a petrol pump is located. Okay, a petrol pump is located on a highway, and the ratio of number of trucks to the number of cars running along the same highway is 3:2. Is 3:2 means first trucks are given, next cars are given. So getting a truck, if 3 trucks are there, 2 cars will be there. If 3 trucks are there, 2 cars will be there. So probability of getting a truck is 3 by 5 and probability of getting a car is 2 by 5. That must be given. That must be given. Okay. Now 3:2. So I repeat the sentence. The ratio of the number of trucks along a highway on which a petrol pump is located to the number of cars running along the same highway is 3:2. That's what I have written here. 3:2. It is known that an average of 1 truck in 30 trucks, and 2 cars in 50 cars stop at the petrol pump to be filled up with the fuel. So how many trucks will be there filling up the petrol? It is, the probability is clearly given. Average of 1 truck in 30 trucks. Average of 1 truck in 30 trucks is given. And similarly, 2 cars in 50 cars. 2 cars in 50 cars to fill the petrol. Understand that. So whenever you work out this problem in the board level, you write all the terms, you name the events, and you solve it accordingly. But in the objectives, try to save the time by writing the direct steps. What are the steps required in this case, and how to get that the Bayes' theorem is to be applied in this case? Because the question you can see now, if a vehicle stops at the petrol pump to be filled up with the fuel, find the probability that it is a car. So whenever in a petrol pump, 2 types of vehicles are entering. One is a truck, another one is a car. So filling up of petrol happens in 2 ways. One is filling up the truck, another one is filling up the car. So 2 events are the filling up of petrol is happening with 2 different vehicles. That means the happening of petrol is happening, the filling up of petrol is happening with truck or car. That is why the total probability comes now. The total probability now, getting a truck into the petrol pump is 3 by 5 into 1 by 30. Simple. favorable probability will come to the numerator, total probability will come to the denominator, plus and getting a car is 2 by 5 into 2 by 50. 2 by 5 into 2 by 50. And what is the question there? Find the probability to be filled up with the fuel to be filled for a car. For a car we require. This is for a truck, this is for a car. So it is 2 by 5 into 2 by 50. So what should it be? If you simplify, you will get that it is 5 into 50. And let us take 4 upon, it is, if you simplify this, you will get the answer. So that's it. That's it. You can try this now. You can try this now. The simplification part, it is easy for you. You can note down the options and you can get the answer. So by Bayee's theorem is to be applied whenever a particular event, filling up of petrol in this case now, is happening with a truck or a car. A truck or a car. R stands for plus. Now it should happen with a car. It should happen with a car. So probability of getting that particular event is taken like this. Favorable probability divided by total probability. Simplify this, you will get the answer. Okay. Now let's see on the problem. Yes. During a power blackout, during a power blackout, 100 persons are arrested and suspect of looting. During a power blackout, 100 persons are arrested on suspect of looting. Each is given a polygraph test. Each is given a polygraph test. Polygraph test means from the past experience, let us see what is a polygraph test. You know that. You know that. From past experience, it is known that the polygraph is 90% reliable when administered to a guilty person. The polygraph is reliable when administered to a guilty person and 98% reliable when given to someone who is innocent. Someone who is innocent. Suppose that of the 100 persons taken into custody, only 12 were actually involved in any wrongdoing. Only 12 are suspicious. That means 12 are guilty. Only 12 are guilty. Means what? Only 12 are guilty means 88 are innocent. 88 are innocent. That is the data given there. 88 are innocent. So, if the probability that a given suspect is innocent, if the probability that a given suspect is innocent, given that the polygraph says he is guilty, is A by B. Is guilty is A by B, where A and B are relatively prime numbers. Find the value of A plus B. Find the value of A plus B. So, understand that during a power blackout, 100 persons are arrested. What we require is simple favorable probability upon total probability. What is favorable probability there? Before writing favorable probability, always I am repeating that whenever you work out the problems based on probability, always write the denominator. What is the denominator? Total number of outcomes. In this case also you have to write total probability. If you write total probability, then you will understand in a better way what will be our favorable probability. That is why try to answer the probability questions first of all by finding the denominator, which is denominator according to the classical definition on probability, total probability. So what is the probability here? So it is guilty. Let us write first guilty person. So guilty person is 90% reliable. Whenever polygraph is applied, it is 90% reliable. So 90 by 100. So according to the data, you can see that only 12 were actually involved in any wrongdoing. Only 12 were involved in any wrongdoing if 100 persons are chosen. So it is 12 means it is 12 by 100 into 90 by 100 plus what should be the reliability if it is applied to an innocent person is 98 by 100. When 12 are found to be guilty, remaining people must be innocent. So, what is given there? It is if the probability that a given suspect is innocent, given that the polygraph says he is guilty, is A by B. it is found to be guilty. This is innocent. So this part 88 by 100 into 98 by 100 is found to be guilty. So this is given to be A by B. This is given to be A by B. Then in such a case, what should be the value of A plus B? What should be the value of A plus B, where A and B are relatively prime numbers? What are the relatively prime numbers? You just think of it, and if you understand, if you answer the question, write the options there. 177, 178, 179, 180 are the options given there. You understand it, you try this problem. If you know what is the meaning of relatively prime numbers, what are the relative prime numbers, if you know, that will be better. Otherwise, we'll see that in the next